Before starting the class, I once again request everyone, whoever is watching the video, please subscribe to my channel. Please subscribe to my channel, like the video and share it with your friends. Okay. Coming to the syllabus here, the first one combination is series combination. For this, let us consider two resistors of resistances R1 and R2. Okay. V is nothing but the potential difference. K antandra plug key, and the current flowing through this circuit is taken as I. And RS ಅಂತಂತಂದ್ರೆ it is nothing but the equivalent ಅಥವಾ effective resistance ಅಂತ ಹೇಳ್ತೀವಿ. How do you define this effective resistance ಅನ್ನೋದನ್ನ ನಾವು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಡಿರೈವ್ ಮಾಡಿದ ಮೇಲೆ ಆ ಡೆಫಿನಿಷನ್ ಹೇಳ್ತೀನಂತ. ಓಕೆ, ಈಗ ನಾವು ಡೆರಿವೇಷನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. Let us consider R1 and R2 are the two resistors. Let V1 be the potential difference across the resistor R1 and V2 be the potential difference across the resistor R2. According to Ohm's law, we have already studied the Ohm's law. It is nothing but Ohm's law states that V is equal to IR. So V1 is potential difference across R1. It becomes V1 is equal to IR1. Same way, V2 is equal to IR2. We are having two potential differences here. Take this as equation number 2. Okay. Now substitute V1 and V2 values. V1 and V2 values in. Take this as equation number 1. Okay. Take this as equation number 1. We are having the potential difference V here. In the series combination, always the potential difference gets divided and current through the conductor remains constant. Okay. So V is equal to V1 plus V2. Take this as equation number 2. Now substitute the values of V1 and V2 in this equation. You will get V is equal to I R1 plus I R2. Since I is common here, take it outside. I into R1 plus R2. V is equal to I into R1 plus R2. Idana equation number 3 anta togolri. Okay. So RS is the equivalent resistance. RS is nothing but the equivalent resistance. Equivalent resistance for the voltage V, potential difference V, for the potential difference V and the current I. Okay, for the current I and potential difference V, that is V is equal to IR. Again we are having V is equal to IR from the Ohm's law. So R is replaced by RS. V is equal to IRS. This is the value of V. You substitute this value of V in equation number 3. Equation number 3 becomes IRS is equal to I into R1 plus R2, or RS is equal to R1 plus R2. This is the expression for effective resistance in series combination. RS is equal to R1 plus R2. Suppose if you are given the 3 resistors, then it becomes RS is equal to R1 plus R2 plus R3. If you are given n number of resistors, then it becomes RS is equal to R1 plus R2 plus R3 and so on up to Rn. Okay. This is how the effective resistance for series combination of resistances is given. This will be asked for 3 marks, okay, or 5 marks. Most probably it will be always for 3 marks only, not such a big derivation it is. You have to compulsorily draw the diagram. Without a diagram you will not be given any marks. ಈಗ ನೀವು ಡಯಾಗ್ರಾಮ್ ಇರಲಾರ್ದಂಗೆ ಈ ಡಯಾಗ್ರಾಮ್ ಹಾಕ್ಲಾರ್ದಂಗೆ ಇದಿಷ್ಟು ಡೆರಿವೇಷನ್ ಮಾಡಿದ್ರು ಅಂದ್ರೆ ನಿಮಗೆ 0 ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ ಎಕ್ಸಾಮ್ನಲ್ಲಿ. ಸೊ ನೀವು ಡಯಾಗ್ರಾಮ್ ಹಾಕಲೇಬೇಕು. ಯಾಕಂತಂದರೆ ಈಗ ನೀವು ಇಲ್ಲಿ V1 V2 R1 R2 ಅಂತೆಲ್ಲ ಬರ್ದಿರ್ತೀರಲ್ಲ, ಅದು ಎಲ್ಲಿ ಇರ್ತೈತಿ? ಆ ಡಯಾಗ್ರಾಮ್ನಲ್ಲಿ ಇರ್ತೈತಿ. ಹಾಗಾಗಿ ಡಯಾಗ್ರಾಮ್ನ ಕಂಪಲ್ಸರಿ ತೆಗಿಬೇಕಾಗತ್ತೆ. ಓಕೆ. ಸೊ ಈಗ ಇಫೆಕ್ಟಿವ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ವಾಟ್ ಈಸ್ ಇಫೆಕ್ಟಿವ್ ರೆಸಿಸ್ಟೆನ್ಸ್? Effective resistance means it is nothing but the sum of effective resistance andre RS. Effective resistance is nothing but the sum of individual resistances, that is R1 plus R2 plus R3 and so on. This is called as effective resistance. Okay, from this expression we can say that in the series combination in the series combination, always the effective resistance is greater than highest resistance in the combination. And this potential difference, V potential difference across the combination, in the series combination, it is the sum of individual potential differences. Adana illi nodidvi now. Potential difference is always the sum of the individual potential differences. And the potential difference across any resistor, it is always directly proportional to the resistor. Potential difference is always directly proportional to the resistor. Howda? So this is in the series combination of resistor nalli ee tara points baribekagutte. Next, you are going to study the parallel combination of resistors. For that, you are going to consider the two resistors R1 and R2. These are having the potential difference is V. This is the plug key, R1 and R2. So the current through the resistor R1 is taken as I1. Current through the resistor R2 is taken as I2. Okay, V will be the potential difference. It's clear that in the parallel combination, always the potential difference remains constant and the current value divides. Now, for the equivalent resistance or the effective resistance, we are having this as the diagram. This is taken as RP. This will be the potential difference and this is the plug key. This is the diagrammatic representation for parallel combination of resistors. Okay. As I have already said, in case of parallel combination, the current divides here according to Ohm's law. According to Ohm's law. Again, we are going to consider the same. That is, the total current I. The total current I through the combination is taken as I1 plus I2. This is equation number 1 at the okay. This as equation number 1 now. Okay. From Ohm's law, we are having V is equal to IR. So current through the potential difference across R1, across the first resistance is V is equal to I1 R1. Or from this take the value of I1 is equal to V divided by R1. Same way, potential difference across R2, that is V is equal to I2 R2. I2 is equal to V divided by R2. ಈಗ ನಮಗೆ I1 ಮತ್ತು I2 values ಬಂದವು, ಇವೆರಡನ್ನೂ ನಾವು ಈ equation ನಲ್ಲಿ substitute ಮಾಡೋಣ. Therefore, I is equal to V divided by R1 plus V divided by R2. ಅಥವಾ V ಹೊರಗಡೆ ತೆಗೆದು ಕಾಮನ್ ಐತೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಉಳಿಯೋದೇನು 1 divided by R1 plus 1 divided by R2. That is equal to V, right? Now, I is nothing but the total current in the combination, and it is for the resistance. Effective resistance is taken as RP. RP is taken as the effective resistance. Then V is equal to IRP, or I is equal to V divided by RP. ಈ I ವ್ಯಾಲ್ಯೂನ ನಾವು ಈಕ್ವೇಷನ್ ನಂಬರ್ 1 ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. ಅವಾಗ ಇದೇನಾಗುತ್ತೆ ಅಂದ್ರೆ V divided by RP is equal to V into 1 by R1 plus 1 divided by R2. Or we can write this one as 1 divided by RP is equal to 1 divided by R1 plus 1 divided by R2. Okay, this is the expression for effective resistance in parallel combination. So in parallel combination, always the effective resistance decreases. Effective resistance, so always it is less than the resistance of combination. The effective resistance is always less than the resistance of the combination. Okay, and the potential difference value, it is same across each the resistor, and the main current is equal to sum of the currents through the individual resistors. And the current through any resistor, it is inversely proportional to the resistance of the resistor. Okay, this is about the parallel combination of resistor. Here also you have to draw the diagram and then go for the derivation up to here. Okay.